Okay, let's get started. Welcome back. This is yesterday I talked about Java beans, and I talked about enterprise beans, and I talked about deployment and getting it all, kind of the big picture about what was going on. And this is sort of the recap slash last sort of lecture on the enterprise Java bean concept. And the purpose of this lecture is to sort of put the pieces together in terms of the deploying aspect. Deploying means actually put it into use. And so we'll go through this lecture, and then next topic on the agenda for today is Corba. So I have a little Corba lecture to go through as well to introduce that technology. So if you missed yesterday, we talked about enterprise beans and enterprise environment and stuff like that. So this one is on the deployment of this enterprise bean. XML as a concept, and enterprise entity bean case study, how to deploy an advertiser bean. So how to put these beans to work after we've created them. So the contents of an enterprise bean, in concept to develop the enterprise bean, you must follow the following files, or must have the following files created in order to deploy them and use them. We have the deployment descriptor that was mentioned yesterday, but I didn't really talk about it in very much detail, so this is the detail on that. The descriptor is an XML file. It specifies the information that about the bean, such as its persistent type of data it might actually be storing, the transaction attributes that are associated with it. If you remember, yesterday was all about transaction management as well. Everything you ever wanted to know and didn't want to know about transactions. And we have the deployment tool that utilizes the utility that creates the deployment descriptor when you set it up through the new enterprise bean wizard. If you're running in an Eclipse environment, you actually have access if you install the EE version of Eclipse that works with Java. You've got this wizard that you can select from a menu that will create this descriptor file for you automatically. And this is what you're going to need in order to deploy the bean, so that the bean, well, I should say the servlet environment knows where the bean is, identifies the properties associated with it, and is able to actually deploy, or execute or run the bean in the environment. The enterprise bean class itself implements the methods that are defined by the following interfaces. The interfaces themselves, the remote and home interfaces, are required for the remote access. And looked at this yesterday, actually, the two interfaces that were part of the, remember that slide that had multiple web server tiers on it, and then we had the interfaces, the home interface and the remote interface that was connecting to the bean. Which is nothing more than the abstraction of how the outside client, depending upon the client type, is actually entering into or going in to access the bean functionality. So the local access, the local and home interfaces are required. For web access, the web service client, we've got the web service endpoint, or that interface is also required. So the remote would be from the web, the home would be from inside of the company. Because you can set certain security issues, certain features can be available remotely, certain features can be available locally. Certain security, some checks, some things like that might also be in order. Then we also have helper classes. Those are the other classes that are needed by the enterprise bean, such as the exception and the utility classes, and all of the things that would go with the bean in terms of its deployment. So here's kind of a picture of the assembly roots with the manifest for the meta information. All of the .class files that go with this bean module. And then here's where the XML kind of makes use in terms of the configuration. It's an XML-based configuration, actually, that's being used with this, which is giving us our jar file, semantics, location information, all of the deployment specs that are needed. This is an automated process. Don't let this slide kind of scare you. These aren't pieces you actually have to make. These are pieces that are auto-generated. If you're using like Eclipse as the tool set to create the bean and go through the wizard, that's going to be created for you automatically. So all you have to do is copy it and put it into the right directory, or run it from Eclipse. But you're not going to be running it from Eclipse every time you run this bean. You're going to be running it on a server. So to physically deploy it, you just copy the information over. You just copy the files that are created, put them in the proper directory, have the server load the files. When the client connects to the server, runs the servlet either through JSP, as we went through yesterday, or through any type of connectivity that might connect the client to the server, the bean can run automatically. So deployment descriptors, these involves packaging of the bytecode, the .class files, together with the Java Enterprise Java Bean deployment descriptor. Nothing more than a configuration file. And what we're looking at then is the deployment descriptors represented using an XML format. And when I say configuration file, property file, well, XML, we're going to look at some basic XML concepts in a few minutes, but XML is nothing more than a markup language, very similar to HTML, but instead of marking up text, which is what HTML does, XML marks up data. So the data in the XML file, and that's why I kind of wanted to say that before I showed you this slide, because there's a lot of reading on that slide. It provides the same type of tag syntax, an opening and a closing tag, and in the middle you've got, as an example, a tag that's defined as first name. And then you have somebody's first name, and then you have a closing tag, and this is all of the way that you're going to represent the deployment descriptor. So you're putting that all into customized tags. This can be created for you automatically as well if you're using the right toolkit. So XML provides convenient modeling language for representing declarative data within the computer application. XML is actually used for a lot. In fact, that little Android thing I just showed you is there's an XML configuration file for that as well that shows you, for the deployment of that, for all of the different pieces of information that are going to be associated with the application so that the host environment knows how to deal with it. Because the host environment is going to read this XML file. It's going to go, oh, this is where this is located, that's where that's located, okay, and configure itself. This is our application name and everything. This is the API we're running with. Yada yada. So XML provides a domain-independent way of representing the data that's easy for humans to read, software to parse. Particular representation of the data using any XML document requires an priori, if I'm saying that correctly, agreement among the producers and the consumers of the data. In the case of this particular example, using the deployment descriptors, is defined in the Java Enterprise Java Bean specification, or in the, shall I say, the API, or the rules associated with this. So, as the complete description of the XML is beyond the scope of this course, the tutorials are readily available. There's a ton of tutorials available. We're going to use a simple example to introduce basic XML. And here's our example. So consider the following data. UML2 and a unified process, and it looks like a name and another name and a date and a bunch of information. So if you take a look at the example, you know that it's kind of time consuming to understand the bits and pieces because there's no meaning associated with it. It's just a bunch of data that's thrown at us. And you can't, how easy is it to answer the question, who are the authors, or what is the copyright date? This particular information, you could probably, kind of guess at it by looking. This looks like the copyright date. These guys look like the authors. That looks like the name of the book. So you might suggest a structural format, and this is basically the purpose of XML, is to create structure out of this format, so you can understand the tokens or the words in combination. You can go, this is the first name, this is the last name, this is, and although this looks a lot easier to read to a lot of people because it's just flat text. What the XML is doing is it's creating this. So we're taking that flat text and we're putting it into this format. And this is actually a really good example of what XML actually looks like in terms of its implementation. So it provides an alternative approach for marking up the data with predefined tabs and labels the data. Here's an example. So we say book title is equal to this, and edition is equal to this, and copyright is this. And you find a lot of people take this to an extreme. In fact, a lot of invoices, a lot of documents, a lot of data is being transferred these days back and forth using an XML markup. or XML format. Because this is lightweight. It's just a bunch of text, but it has a lot of meaning to it. You're sending, well, this particular example, you're just sending authors' names and a publishing date and stuff. But it's a lot easier to send that than it is sending like a binary file or sending other information. So computers talk to computers via XML. And yes?
Can this be readable by your web browser?
Interesting. There are some good question actually. So there are some web browsers that view XML code, but primarily the audience is a computer, not a browser. So XML was never really designed for web browsing. However, you can mix XML in with HTML code, and all you're going to see in the browser is the HTML code. Yeah, because web browsing, what is it? It's HTTP protocol implemented in the form of a text display. In the old days, they actually were just command line displays of the page. But that GUI graphical interface we have now through, the I was going to say Netscape, but Firefox and Internet Explorer, and so it's an HTML parser. Actually, it's fairly easy to create your own browser. Just parse the HTML code out of it. And, unfortunately, and this might explain why some browsers aren't really compatible. A slight tangent on the topic, but some HTML text is non-standard. Some of them is XHTML compliant. If it's XHTML compliant, it means it incorporates XML standards with HTML. So that's what they refer to it as XHTML. Most browsers are XHTML compatible these days. Some of them, there's differences between the way Internet Explorer, that actually supports the document object model, interprets stuff, and their version of it is slightly different than Internet Explorer, slightly different than other browsers out there. And the differences are in the standardizing and the version of HTML that browser was meant to parse. So XML, we're looking at parsers. So people love to create XML parsing programs, which is pretty easy. You just read in the file, take the tags, parse the information out, and assign it to variables, essentially. That from the tags, you know what the variables are, and hopefully, and you can easily parse this out. So XML parsers are all over the place, and they're specific towards the format of the XML. And one of the other differences as well between HTML and XML as a concept is HTML has predefined tags, bold, underline, all that stuff, right? XML doesn't have anything predefined. How do you know that there's going to be a book title? How do you know that there's going to be an author tag? So it's usually the parser that defines the tags, and then you can come up with your own vocabulary, come up with your own tag set, and tell the parser to use this vocab, use this dictionary, or use that dictionary, and then the parser can go through it. So one of the reasons why an HTML website, an HTML interpreter like Internet Explorer as an example, or Firefox, can't parse XML because it doesn't know what the tags are. So a lot of them, the parsers are kind of generic. It just takes and builds a tag list from what it sees from the XML tags, and then puts in, first name space, and it gives you the information that's associated with the tag. So it's reading the tags and it's dynamically determining what tags exist. But it really can't do anything with it. It doesn't know how to process it. That you can use these tags and actually process the data, use it as data. Apply for put the things into a form, and this could be form data, and then, or it could be not necessarily information from a form, and it could be used for, well, in this particular case, just cataloging a book, I would say, but you could use it for applications of all sorts of different natures. And the reason why this is being mentioned along in the context of Java beans is because this is the descriptor format. The descriptor is created in XML so we can find the right bean. This is a description that the web interface, the parser, can understand, that can be used to locate the bean, to provide the interface to the bean for the functionality that we're interested in getting. Sort of like the way JSP was used in my descriptions yesterday in terms of being able to compile the JSP code that's dynamically changing, and if there's a change to the JSP file, that's compiled, and then that's put into a server, and it's served up. It's ready to go. Well, so the XML is read. It's not really compiled. It's interpreted, and then the proper bean interface is being used as a result. So, although this XML version of the data is more cumbersome to read, it does have a number of useful features associated with it. It's reasonably easy for humans to read and understand. Easy to write. A computer program that can parse it, locating authors, copyright, book, all sorts of different information from those tags. And it uses standardized format to structure the data. So basic XML. And this is sort of your tutorial, because unless you're using a tool set that actually creates this, you'll have to write the XML information yourself. You actually basically have to create. In the old days, people just created their own XML descriptor interface. So it's a bit time consuming, but here's some basics. It represents elements and attributes that are associated with the elements, just like HTML. Consider it fragments, as here's an example. On the previous slide, we had book title, the name of the book, in quotes. And this is actually kind of why XHTML basically requires quotes around it. How are you going to tell what the attributes are? So you can write sloppy HTML code, and it works in the browser because browsers are sloppy. But you can't write sloppy XML code, because then you can't tell the difference. Unless you're just parsing it character by character, you can't tell the difference between the attributes and the tag or the element. And they actually are using the same type of terminology with HTML. Elements are elements, attributes are attributes. It means the same thing. So here the XML element is the example. In this particular example is the book, and the book element contains 4 attributes. It contains the edition, the copyright, the ISBN number. The syntax of the XML dictates that the elements begin with the start tag that consists with less than, that consists of less than a sign, here we go, just like HTML. Opening arrows, less than, greater than signs inside of a starting tag, and this is the start tag up here. It says book title. And then we have a closing tag that says, just the same syntax as HTML. The only thing different, actually, between HTML is that because these items, these data elements, and their attributes are assigned in sort of a more programming method than an HTML method. Because inside of this tag, we have edition, copyright, ISBN. So these aren't separate tags in themselves. This is just separate data. This could all be on one line, however. And if it were on one line, we'd see the opening and the closing tag that's defining the data. So it's a little bit different in terms of the HTML, although it's very similar. And when I'm talking about the differences between HTML and XML, it's the syntax is what I'm comparing, not the usage. The usage is completely different. So each attribute in the element, if any, consists of attribute names followed by equal sign with an attribute value that's always in quotations, which is why XHTML always requires attributes to be in quotes, because XML requires that. And just as a side point, because I mentioned XHTML and HTML and XML, we know that the two of them are, XHTML is a combination of XML and HTML. The only thing that really differentiates XHTML and HTML is that XHTML is XML compatible or compliant, which means if you put XHTML on your basic tag for essentially the type of document that it is, it can be read by XML readers theoretically, and the tag should be understandable in terms of the formatting. If it's not compliant, it's for compliance sakes. In fact, you can go to W3C's, upload your document, and it can tell you whether it's XHTML. And if you don't have quotes around your attributes, it's not going to be. It's going to fail. So that's just one of the items. The other one is, the case sensitivity of tags using, if it's in lowercase here, it's lowercase here. If you take a web class, you can actually learn all the differences between all the different versions of XML, HTML, and XHTML, and why people pay so much attention to that stuff. It's for compatibility. When you start writing programs that are interacting with other programs, then all of a sudden you start thinking, wow, this has got to be compatible, which was kind of interesting because, not to keep bringing up that example of that Android thing, but I took an HTML, but the I2 website is actually fairly compliant with XHTML because there's an XML parser that's working on that HTML page of that LMS website, EMS website. And it's consistent. The tags are actually pretty consistent because when I logged in as a student, I was surprised to see, it's consistent. It removed the tags that I didn't want to show, but they were consistent among the faculty login versus the student login, which is nice, actually. Tells me that whoever developed that system is using a pretty consistent format and is abiding by a pretty good standard in terms of the document naming and the element naming within the documents. And because of that, I can build a wrapper on top of it, and I know that I'm not going to get some funny tag showing up on the screen that doesn't belong there, because everything's labeled properly, everything's consistent. So in terms of development for future projects for interoperability between different components, there's a lot of merit to consistency. My point being. All right, back to basics. The semantics require the starting tag and all of the elements that are followed by, until the end tag actually occurs, consistent with the less than, the slash, and here's the closing tag. What we're really doing is calling this content. So the information between the tags is the element's content. And if an element has no content, referred to being empty, it's an empty element. XML allows for empty elements. So if we left something empty, we should be able to show that it's empty, and so come back and say, hey, put something in there, you left it empty, or we don't have the information that we need. So for all practical purposes, the following two statements are equivalent because of, as I mentioned before, we can put everything all on one line. We don't have to actually make it non-empty. And if it's empty, we don't actually have to put anything at the end either. It's just empty. So, in terms of the deployment descriptors, which is why I'm bringing up XML as a concept, so one of the goals of the middleware enterprise Java Bean environments is to allow software engineers to focus primarily on the business solutions and not on the programming aspects, and freeing them from the tedious details required from large-scale enterprise applications. You're building bitsy little pieces of components. So one of the interesting side effects to this entire configuration is that each developer can be on an island of its own, doesn't have to worry about the big picture. Their bean functionality is their bean functionality. And so you can divvy out the work, have one person working on this particular feature of the application and another person working on that feature of the application. And it's completely separated, and it's the descriptors that tie everything together so that their work is completely, their bean, and one bean module can be replaced by another one. It's not going to affect the entire big system. So it's kind of interesting when you compare that to, traditional style programming. When people work on a program, it's all together. It's all separated out all over the place. So there's no uniformity in terms of how consistent the functionality works. But there's the interfaces and the descriptors to the functionality from an application level that makes it all uniform. So it's kind of interesting the way that it is. If you compare Java development and enterprise servlet development to old traditional style CGI development, completely different in terms of the programming aspect of it or in the configuration. So one way to help simplify the deployment of the enterprise beans is to make certain that aspects of the deployment process data-driven, and consequently everything is in a declarative everything is declarative in nature, and you're declaring these aspects and you're putting them in the deployment files and the descriptors. So instead of writing the code required to support the transaction process within, and among all of the different beans, it's simpler to specify or to declare that the bean has a certain transactional processing capability, and then let the container automatically generate the code required to support the capability. So bringing this back together and with the container concept we talked about yesterday, let the container manage the beans, and if the container is managing the beans, you add the transaction processing and the transaction support and the transaction bean to the container, and then you can simplify the entire concept, which is why kind of containers are sort of important in terms of this abstraction, because the container is keeping track of all the little bits and pieces. So something has to give you that encapsulated application kind of component, and the container's doing that. So within the Enterprise Java Bean environment itself, the descriptors are made in XML files, and they're containing the deployment descriptors. So this was referred to as the deployment descriptor. So in the Java 2 EE platform, they're made up of one or more individual modules themselves, as we're looking at, and the modules are deployed. They have deployment descriptors specific to the module, and so that the enterprise applications also have their own deployment descriptor format. So as we mentioned before, all these different modules. We have the bean module, we've got the container module, the transaction manager, the resource managers, all of the different kind of things put together. The descriptors are consistent among all of the different, and they identify all of the different components or modules. It's all written in Java, so it's all kind of compatible across the board. It's the concept of what it is that the component is doing that's going to vary. In terms of the module descriptor, they're defined in the XML files named Enterprise Java Bean / jar XML, which is going to be the blanket to XML file descriptor to, XML descriptor to identify the different components that are enclosed. And that's this piece here, going back to that's this piece over here. And these are, you don't have to worry about any of this stuff if you use one of those auto-generating tools that creates this for you automatically. But this is the background information that's associated with it. Never actually even have to write an ounce of XML code either. So if you're using one of the auto-generated programs. So the deployment descriptors, let's take a look at the jar files. The top level elements of the Enterprise Java Bean deployment descriptors are elements used to define the application metadata, the structure, the assembly information, and the archive file for any of the client files that are associated in there. In terms of the jar files, an Enterprise Java Bean jar represents the deployment jar library that contains the server-side code and the configuration of the module. It's just basically compressed into one file and it's used and called. It's kind of like, sort of like the same philosophy that Java uses anyway. All your library files, everything, even the component, the connector, the Java connector for JDBC is in a jar file. Everything is deployed via jars. It makes it easier. It's just one file instead of all a bunch of stuff inside of it. So the same technique follows through for enterprise beans. So during the deployment, the Enterprise Java Bean jar file is placed in the meta-inf directory of the jar file. So an entry and session beans defined within that environment must have .class files for their implementation, and the .class file is a Java file. It's a compiled version of a .java file. For the home interfaces, the remote interfaces, as well as the dependent classes archived inside of the jar file. So if you remember the interfaces that I talked about in terms of the RMI engine, which basically turned into a .class file. Well, it's the same concept. The interface is the interface from R is the interface from Java and enterprise environment as well. Those interfaces are enclosed and they're included in the Enterprise Java Bean file. any client stub as well, and interface classes needed to access the Java beans. In particular, can be placed in separate client jar files if needed, so they can also be included. And then the URL of this enterprise Java bean jar file can then be specified in terms of the element. So you can call it. So it knows it's running from the servlet. It knows because of the syntax of the XML file, the descriptor knows to go run it. So you might think of the XML interface descriptors to these jar files as the web it's HTTP compatible because you can send it and receive it via that protocol. So it's the web equivalent to the interface to this application. So, and it is the web interface to make sure that's clear. So any enterprise Java Bean client and beans associated with the server side can then be automatically received and downloaded through the interface and the subclasses from the client's loader that reaches that particular URL defined by the jar file element. So it goes in, the client end of it goes in through that XML interface descriptor, comes in, pulls the jar information, runs it, sends it back. So it knows how to find it on the server. So if no automatic class downloader mechanism is supported or used, the library should be installed in the client's machine. So you can actually put it on the client side. It's distributed. It can go anywhere it wants to. So normally you're going to find it on the server though. So here's an example of an application deployment descriptor, and it means absolutely nothing to you probably. It's an example. This particular example is called an advisor test bean, and it's going to be located. Here's our URL for it. Actually, this is still out there as a reasonable example that you can use if you go to that URL. It's loaded out there on the internet, and has the XML file is identifying it as an enterprise bean. And the entity itself is identified, and you can go through all the tags, but it's not going to make any sense to you unless you see it. But this is a pretty simple / pretty generic bean that would be identified by this descriptor that would be called from a web application when it was running. Other methods, we have the use method. Other methods, we can use the asterisk here for a method name, and then we can define a method by this asterisk. So instead of defining one of each method, we use this asterisk. Is asterisk? I think it is. Star. What is that symbol called? It's Shift 8. Asterisk? No. Am I saying that wrong? Am I having a brain? It is an asterisk. Okay. I'm having a brain fart right now. I'm like, what is that thing called? I'm so used to saying ampersand, that's why. I'm like, and it's like Shift 8 is asterisk. Okay. Just sounds weird to me right now. Much easier to define a method this way and then use it over and over again. It creates reusability in terms of defining. So, defining one for each one of the methods, you use this asterisk here. It's much easier. There's a vendor-specific jar file format in which we have a Sun Enterprise Bean jar XML file that's going to be making some definitions for, again, this Enterprise Bean that's defined as the advisor in this particular example. So they all look the same, actually, after a while. So in terms of the procedure, the deployment procedure, and this is vendor independent. Each company is going to have a slightly different process. The process for, independent, so they're all going to have the same process. The process for deploying it involves establishing environment variables, configuring the server properties, compiling the Java code, creating the XML-based deployment descriptors, and packaging the archive files, and then deploying the archives to the Java 2 EE server and environment. So you can set, and here's kind of the step or the process to go through. You set the J2 EE server environment variables, so they must be running on the server. So hopefully they're part of the operating system platform. Excuse me 1 second. So set the environment variables for the server. Configure them in terms of setting the properties that are associated with it, so they suit the particular needs of the particular network environment, whether they be security properties, access properties, whatever happens to be involved with that. Compile the application code. Create the application deployment descriptor, which may be done for you automatically, actually, depending upon the tool that you're using to compile the code. Create the vendor-specific deployment descriptors for any vendor information that you're using, third-party tools and pieces and components of your application. Because no standard means exist to bind standard enterprise bean reference names to server names, that JNDI-based naming service, so vendor-specific deployment descriptor mechanism is required for performing the actual mapping, because it doesn't exist in terms of tool sets. Basically it means if you put in third-party stuff, you got to map it yourself and manually set it up. Packaging the application code itself, and then starting the server and then running the program. In terms of the application code, it's just all of the compiled classes that are put inside of a jar file and then loading the jar file onto the server. In terms of starting the server, usually the server can have an automatic script that runs that sets all of the, and makes instances of all of the objects as if they were locally run, and it makes it available when the server actually starts up. And for most of the server technology, it's just a matter of putting things in a certain directory, and then it knows to go to that particular location and start all those server objects, or invoke instances, I should say. Create the application deployment descriptor, or do it from an automatic method. Used to create, you can usually there's an application deployment descriptor must be created to collect one or more of the web and the components themselves, make it into provide you the application concept. And then package the Java 2 EE application code, and then deploy the enterprise application code. So we have a lot of different pieces and parts, you might think, in terms of the application deployment. And obviously running through these steps is not really going to give you everything you need to know about it. It's just an overview of what's involved if you were to take on a project like this and missing some of the steps that are involved in it. So long story short, you're going to either follow an automated system. Oh, this is wrong. Client server in the internet. I reused it for my client server in the internet class, but this is the Java EE class, which is pretty much the same thing. What my comment I was making on this is either you're going to follow through this manual process, or you're going to find a right tool set to deploy it correctly. And there's a ton of third-party tool sets out there for Java Beans and stuff. And NetBeans actually is a good one for that, as well as Eclipse in terms of the deployment tools. And the deployment actually kind of changes with different server types that are being used. So most likely you're going to find the tool set that's going to match the server environment that you're going to use. That's going to give you the automated hopefully the automated interface to all of this. And in terms of writing the components, this is all Java code. So you're writing the bean component, you're creating the descriptor files, the XML files automatically from the information that's coming from the source code, hopefully. Okay, the second part of this lecture, as I mentioned before, that has the client server and the internet title to it, which I need to edit. Basically came from a different course that I used to teach here that don't teach here anymore. And instead the course got renamed to Java EE Programming. So session beans and a JSP tutorial. We actually covered JSP yesterday, so this lecture is it's kind of deceiving. It's not really providing a JSP tutorial. But it's going to give you some concepts in terms of the different bean types. The session bean, we talked about the entity bean type yesterday, did not talk about the session bean yet, or outside of a definition of what it is. Session beans are a set of objects that can implement the business logic in the application. So they tend to be responsible for a group of related functionality and not using persistent storage. So it's just like the session concept in terms of web programming and other development. The bean itself is just Java code that manages the session. in terms of its complex functionality. Types of session beans: we have stateless beans that do not care declare. I think the care should be taken out, but they don't declare any instances so, from the class level variables. So the methods contained within them can only act upon local parameters that are stored. There's no way to maintain state access across method calls. And they provide excellent scalability because the containers themselves do not keep track of their states across method calls. So the session bean is keeping track of the information that would not normally be there in terms of the states between method calls and things of that nature. As an example, provide some generic service to clients like signing in, or a catalog bean, browsing different products and catalogs for generic information given to the client. As an example, if you were to set up, let's say, a Barnes & Noble app or something, or actually just call it a generic bookstore app, and you had different publishers set up that you were logging into, you can create a session bean to keep track of the users. This is the author I typed in, and this is the information. Because if you think of the concept, otherwise you'd be passing information back and forth between different bean components. If you had one bean that looked at McGraw-Hill as a publisher, as an example, and another bean that looked at Pearson's as a publisher, how are we going to get the beans to communicate? So we create another session bean that keeps track of state or does not keep track of states, that keeps track of client information, let's say. So we don't have to keep asking the client, what was that author again? What was that book again? What are you looking for? So it's sort of like the same thing that we do with session information, username, password. We keep track of that session stuff so we can reuse it among different components that might be associated with it. So stateless isn't going to save any information, isn't going to declare any between different classes. Stateful is going to capture it. So it can hold client state across different method invocations, contain conversational state on behalf of the client, cache information from the client, not stored on the client, stored on the server, because the bean is running from the server. So it's possible to use an instance variable declared in the class definition of a session bean to keep track of information for each one of the clients. Clients will then set the values for these attributes and then use the values for other method calls and things. So it's a way of the beans and the methods to communicate with each other without after coming back and asking the client for this information. And shopping cart for an online store is a good example of a session bean that keeps track of states and stateful information. It's going to store it as a resource. It's very resource intensive, actually, as well. Therefore, it doesn't scale well for stateless beans. So these guys here, the stateless beans, you can put a lot of them in there, and they're just going to keep track of the coordination. The stateful ones are each client is going to have its own instance created instead of one instance being used for all clients. Because if you think of the concept, we want to make sure everything's separate. So each instance for one client is going to have their name, address, telephone number, or stuff like that, and we're not going to share it among all different instances. Decisions. How do you know when to put one of these together? How do you know when to use one? How do you decide whether a given enterprise bean should be a session or an entity bean? And entity beans in comparison. So session beans are great for implementing business logic, processes, workflows, stock trader bean with a buy and a sell method associated with it. Entity beans are persistent data objects of the application environment itself. Get price, set price, stock trader. Perhaps a session bean can call a method in an enterprise bean in terms of an entity bean to actually have that type of functionality be performed. So it's sort of like having to decide which classes to create in an application and having to decide which session or which entity bean to establish is another decision you have to do. So in good practice to have a client-only interface with session beans and a session bean interface with an entity bean for those reasons that might be associated with a single point of entry for a client. If you have a separate session being associated with the entity, with the session, separate session bean associated with each client. Each client goes to the session bean and knows the state of what's going on with their activity, what screen they should be looking at, what information is housed for them, and then have entity beans that are established for each one of the different functionalities that the client is actually using, and you use them in combination, and then you get essentially a lot more business logic that's applicable towards the application development. So calling entity beans directly tends to push business logic into the UI. Yeah?
Can this bean data be ever clear?
Oh yeah. When the client goes away, the beans go away. The bean data will go away. Session beans are automatically cleared. Create a new instance, die, garbage collected. So it's definitely, in fact, I sort of went over this yesterday in terms of the bean technology. There's session tracking per client, and then there's information for all clients that's created, and it can be flushed at any time. Usually it's with connection and the disconnect. The server itself keeps track of that state, though. It's managed by the server. So you can configure the server to keep all that information, or you can have it automatically disposed of when the client goes away. So the UI is really close to the user. It is close to the client. It's more vulnerable in terms of security. So sometimes the business logic, you don't want it as close to the UI. In fact, if you put up a layer of beans in front of the UI, you can add the security, you can add the wrapper around the business logic, push it back further towards the server. So UI doesn't have to be dependent, but changes to the entity bean or session bean shields the UI from these particular changes as well. So you don't have to worry about changing UI components when you've got bean components that are providing that interface instead. So the farther you push it back, use the entity beans, use the session beans, the less you have to do in terms of constantly changing the UI to take advantage of different applications, different states, and different things that might be going on. So usually many more entity beans, so restricting client access to session beans, conserve server and network resources considerably as well. So here's the autonomy of the session bean. This picture might actually put the pieces together for you. Here's the UI code over here, and here are the two interfaces I talked about yesterday, actually, the home interface and the remote interface that are coming into the home stub and then the bean stub for the remote user that's going into the server for the home and the bean interface. You can think of the bean as the remote if you want to. And then the bean classes that are inside containing the session beans, the business logic, all of the implementation of the program that's running. And then we have the interface beans coming in to access that information. And usually by the end of this, people go, there's so many different components to this. There are. So it's different levels of abstraction. So the UI calls the method of the session bean as it requires the functionality that the beans are providing. So the beans are sort of the worker bees that provide the access to the functionality. You just call the bean. And there's a lot of beans, and you put them in a container and you have it container managed. And then all of a sudden you have a little bit more automation to all of the little bit of details. So session beans can call other session beans and entity beans. It doesn't really matter who calls what. Theoretically, client's going to have a single point of entry in, whether they're local or remote. They're going to call a bean, the bean's going to call another bean, that bean's going to call another bean. It's going to do something. So here's another look at it in terms of the interfaces. So the interface from the home object, the remote objects from enterprise, they're all coming from the same location. Remove, get the data, get the home handler, get the handler, remove, primary key, information is coming through, let's say, to an interface that's going to be connected to it from a stock trader or from different parts of the interface for the different pieces of the application that the client is actually invoking. And then the stock trader bean is going to be responsible for this. So in essence, what you're doing is you're taking one application that has a lot of functionality. You're separating it out into separate, smaller applications, and you're putting all the applications together via the interface. So the interface comes in and says, oh, you want this bean. Oh, you want that bean. And then it makes instances, and beans call beans, and beans call other beans. Think of them as smaller pieces of the same program, but they're it's kind of like the opposite of drinking coffee, actually. When you drink coffee, you've got a bunch of beans that have been filtered through hot water. And you've taken the juice from all the beans and you're drinking it together. But all that coffee came from a ton of little Java beans that were roasted together, or what do you call them, boiled together or whatever to create that bean abstraction. So you're going backwards through the funnel and you're getting at the bean components from an implementation standpoint, which is really the same thing. So this is the big picture of what I was showing you yesterday. And some people may or may not have gotten it from the presentation. This is a better looking picture, but it shows all of the different pieces of the Java servlet pages. This is the easy part to understand. It's the client. It makes a request, it receives a response. The web server, yesterday I had it all tiered out into different levels. This is all combined together. So you could separate this out and you'll be looking at the slides I showed you yesterday, where the web server connects to the JSP container, connects to the server, connects to and then all the other components are subparts of it. Web server is going to make a request to the container that's going to have all the beans and the technology in there. The JSP component of it, the page implementation, is cached and compiled on the server. And after it's compiled, the executable code that's running from the Java code is calling all of these other components from the container. So JSP is translated into the implementation class. The class is in the container. The container has all of the other bean components that that's using to encompass this application. And in essence, the client doesn't know anything. It's transparent. The client makes a request. The request goes to the different levels, comes back, and the response goes back to the client. So it really is client server, but it's distributed. Because these don't necessarily have to be on the same server or in the same location. They can be all over the place. In fact, as long as the web server knows how to get to the container can have pieces all over the place. It doesn't really matter. Normally you're going to house them all in the same centralized location, although for fault tolerance that may not necessarily be a good idea. But that's the big picture in terms of the abstraction that we've been talking that I've been introducing this weekend. So, resources. These links should still work. Free books, free websites, white papers, everything you want to know about JSP, servlets, Java beans. It all gets mixed together, and you can probably see why from looking at this overview. You can't talk about JSP without talking about web servers, without talking about containers, without talking about beans, without talking about sessions, without talking about entities, and all of the other bits and pieces of components. So the objective of the last few lectures has been to give you the vocabulary and to give you this kind of abstraction as clearly as possible. Although you can't really, I don't know, most students don't normally get it until they actually start working with it and start implementing it. But it's hard. It's like the chicken before the egg kind of concept. If you don't know all the vocabulary and you don't know the big picture, it's hard to see the smaller details. But it's hard to see the big picture until you see the smaller details. So what will end up happening is you'll start working on a project and you'll start writing beans, or you'll start working with servlets, and you'll start using. You don't really get it from the JSP perspective. You can program in JSP for a long time and not understand it because somebody else is loading your JSP into the servlet. Until you start writing the enterprise beans and you start working with that environment, one of these days, the light bulb will come on, and you'll go, "That's what it is. That's what this whole servlet thing is all about." And then you see the big picture from it. But you don't have to do any of that for any of the assignments for this course, which is good. And the interesting thing is you will find that when you start working with this stuff outside of the XML, which you'll probably never write either, there's so many XML generators, you may end up writing some basic XML stuff. everything is all Java programming, so from your level of abstraction, it doesn't really matter if you don't see the big picture. As long as you see the smaller level details and know how to do the implementation from a Java language perspective, you end up learning it from the particular company that you're working for and their configuration. Because you got a lot of choices to make, and the interface to it is going to be different depending upon the company. Not every company is going to use the same model. They're going to have different models. So, anyway, that concludes the JSP stuff. The next lecture, I'm going to start in a few minutes. So I'm going to stop this video.